Welcome, everyone. Good morning, good afternoon, good evening, good day, depending on your time zone. We're really happy as an YR Foundation to have this diverse and extremely large audience today. We have speakers from 5 continents and participants from all over the world. It is my pleasure to guest Isabella Velásquez today from our studio. Our studio was kind enough to become a silver sponsor of this WIRES conference. They were also supporting us in the previous years. Isabella will present the usage of R with other tools like Python Tableau. And we're extremely happy to have such experienced people from our studio talking at our conference. So Isabella, thank you for joining and investing your time, and the floor is yours.
Thank you so much for the opportunity to join you at YR today. Hi, everyone. Today, we're going to talk about using R with Python, Tableau, and other tools. My name is Isabella Velásquez. I'm a Senior Product Marketing Manager at RStudio. And previously, I worked in multilingual analysis teams, and I've used tools like Python, Tableau, SQL, QGIS, and others. However, I am first and foremost an R user. I'm a co-organizer with R Lady Seattle, and I use R on a regular basis. And I'm really excited to talk about this beloved programming language with you today. For a quick look at the agenda, we'll be talking about packages that help you use R with other tools. We'll go through a few walkthroughs with Python and Tableau and touch on other examples. And I won't really be discussing the installation and the setup of these packages in too much detail because the package developers and others have excellent documentation, wonderful demonstrations available. And instead, I'll provide a link at the end with additional resources for all of the packages and tools that I talk about today. And I also want to note, there are many tools for interoperability with R, and we will be only covering a few. So if you have a package that you want to mention, please share it in the chat. So this conference has many wonderful examples of why R. R is an incredible open source programming language with an inviting community that supports others in data science. And the transparency of the programming language allows it to be trusted and reproducible. And because of its flexibility, there are applications for all kinds of industries or organizations. You could run rigorous analyses, create dashboards, the list goes on and on. And in addition to all this, our users provide specialized packages to connect to other data sources, modeling frameworks, and resources. And in other words, these specialized packages help enable interoperability, or a way to work across tools because they understand each other. You may be thinking, R is such an amazing language with incredible capabilities. Why is it important to have interoperable tools? So the first is that you're building on prior work. You can use existing code and knowledge. So for example, if there's a library in Python that's not readily available in R, rather than having to translate what already exists, you can use your interoperable tools to use the Python library in R. And this reduces the effort and overhead to get your work done. Second is choosing the right tool for the job. Often data science teams feel like they need to lock themselves into a particular language or tool. And with interoperability, you can use many languages and frameworks, and instead of focus on what needs to be done and the best way to do it. Interoperability lets you expand what your team can do and make better use of current workflows while using the full power of R. So this means you can do better data science work. A third reason is if interoperability exists within your tools, it makes work a lot easier too. It's easier to pull data in and work in the language you prefer. For programming, you can avoid switching environments and instead code in one place. And you won't get stuck trying to solve data quality issues or rework data to a new format during data handoffs because your workbook or workflow will be seamless and easy to navigate. And your team won't be stuck unable to work together because one person uses one language, the other uses another language. And linking tools together leads to better collaboration and efficiency for teams. And then another important point is with interoperability, the work remains reproducible. Rather than having code and data spread across different files, interoperability can bring them all together in one place. And so anyone, regardless of their preferred language, can run the analysis. You can quickly pick up another team member script and run it regardless of your preferred language. So next up, we'll be talking about some examples that demonstrate interoperable tools. I try to think of some examples that illustrate these reasons for interoperability separately, but as you'll see, they're actually all quite related. And I hope that's a good indication that interoperability is very much worth it. It improves data science in multiple different ways. So first, let's talk about Python. Python is a popular open source programming language, very often used in the data science world. It has many different applications, such as machine learning. And since it's open source, there are also many functions and libraries that exist in Python and may not exist in R, and vice versa. So what happens if there's a Python library that we would like to use alongside our R skill set? How do we avoid having to recreate it in R? So the Reticulate package provides a comprehensive set of tools for interoperability between Python and R. You can call Python from R source scripts, import Python libraries, and translate between R and Python objects. So for example, between R and pandas data frames, or R matrices and NumPy arrays. And with it, you can create R markdown documents or Shiny apps that call Python as well. So back to our question, we can use the Reticulate package to build on prior work and use the Python library we need and port it back into R. And this makes it really easy to use both languages all within the same R script or R markdown document. So for example, there's a very interesting paper by Professors Yanai and Lurcher. They wanted to see if students would change their approach to projects if the students were told what the expected outcome of hypothesis testing would be. And I have the paper here for you so you can find out the results. It's very, very cool. But in the paper, the authors created a data set from a cartoon gorilla. And using the Python library Pillow, they were able to get the coordinates for the lines of the cartoon, and then they ported it back into R and used ggplot to plot the image. So say you're like me and are not really a Python user, but want to try this out for yourself. Instead of making a recreation of the Pillow package, we can use it within R using Reticulate. And using Reticulate, we can also call the Python object created by Pillow back into R and visualize it with ggplot too. So let's see what this looks like. To try this out, you can go into this RStudio Cloud project link. We set up a project with this file structure as an R markdown document, and then a folder containing the original cartoon gorilla image. Sorry, are my slides progressing?
Yes, they are. They are.
Okay, great. Thank you. They're stuck on my screen. So I'll walk through what's happening in each chunk, but please note if you're using the RStudio Cloud environment, everything will already be installed. So if you run this on your own machine, you may need to configure some things. First, we're setting up our packages. So we would install them if they weren't already installed. Still in an R chunk, we let R know which Python to use with use Python. Now we can install the Pillow library with Reticulate. And notice that we're still inside an R chunk and installing a Python library. And now we can use a Python chunk to import our Python modules. We're importing NumPy and also image from Pill, which is the library that Pillow is forked from. And we create the cartoon image file, or we open the cartoon image file. And then we create an array of coordinates of the outline of the cartoon called chords. So great, now we have a set of coordinates for the outline, but how do we bring that back into R to visualize it? For that, we use the Py object. And by using Py, we convert Python objects into R objects. And from there, we can use the object just like we normally would within R. And in this case, we're recreating the steps from the paper that the authors used to create their data set. So using sample, mutate, etc. And now we can use the R object to visualize the coordinates from Python using ggplot2. And here's another example using the data that we created. And I also want to note, while this example was in R Markdown, we can also use Reticulate to write inline code within the RStudio IDE. So this clip converts an R data frame into a Python one, and then running the crosstab function from pandas. Okay, next up, let's see what it means to choose the right tool for the job. So Tableau is a proprietary product. It allows creation of interactive dashboards very quickly with point and click features. It's extremely popular, especially in the business intelligence world. So you may find yourself in an organization that uses Tableau as their main reporting tool. However, Tableau doesn't run models by itself. So how can you make sure that you can use all of the power of R when presenting results in Tableau? So the Plumber Tableau package lets you do that. There's a Python equivalent called Fast API Tableau, but for this talk, we'll focus on Plumber Tableau. Plumber Tableau lets you call external R code in real time from Tableau workbooks via the Tableau analytic extensions. You write your R code completely within your programming environment, turn it into an extension, and then use a snippet to connect your Tableau dashboard. This is really nice for multiple reasons. First, it means you can code your model in R just like you normally would in the environment that you like, for example, the RStudio IDE. Your code isn't limited by the Tableau environment. You can also manage your packages or use version control. You can debug in your environment. Essentially, you can do your data science work like you normally would in R because that's the right place to do model development. And the Tableau dashboard shows the output of all that work because it's where you want to visualize results. I want to note that this walkthrough uses RStudio Connect, a publishing platform from RStudio for the work created in R and Python. RStudio Connect lets you share Shiny applications, R markdowns, and much more in a convenient place. And you can control access, schedule data refreshes, and much more. And in this case, RStudio Connect is the tool that lets Tableau and our R model talk to each other through a published Plumber API. So for this example, it won't be completely reproducible without an RStudio Connect account. So I will walk you through the steps of creating the model, transforming it into an API, hosting the API, and integrating it into Tableau. But there are some configuration steps I'll skip, but they are all available in the Plumber Tableau documentation. So say we've created a model using tidy models, which is a collection of packages for modeling and machine learning that use the tidyverse principles. And I can't show all of the code here, but it's available in the RStudio Cloud link. And this model predicts the occupancy rate of Seattle parking spots in various blocks around the city based on the date. And the data is from the City of Seattle Open Data Portal. So we want Tableau to visualize these results. And if somebody changes something, to calculate the predicted values of the model and visualize it back in the dashboard. So now we convert our code to a web API using the Plumber package. And if you have not used Plumber before, it is amazing. You can use comments and they make your R functions available as API endpoints. So they are available to other people or tools on the web. And in this case, we take our model object and put it into a function so that it predicts the occupancy rate of a place in the city based on the block ID and the number of days in the future. Then we add the Plumber comments to turn this into an API. And then some of these are special comments from the Plumber Tableau package to turn this into a Tableau extension. And these special comments help Plumber Tableau respond to requests from Tableau. Once you run the API, you'll see an interface like this, and it will let you try it out. You can input values and make sure that everything is running correctly. And then you host the API. Once hosted, Plumber Tableau automatically generates a documentation page. So for example, this is what you see when you view the extension on RStudio Connect. And all the information that you gave in the special comments before will show up here. And this documentation has information on how to configure the analytic extensions in Tableau if you click the buttons on the left. And the Plumber Tableau extensions are used within calculated fields in Tableau by using Tableau's script functions. And so this is what you'll use in the Tableau workbook to call the extension endpoints. You can copy and paste that script command into a calculated field in Tableau and replace the argument placeholders with the actual values from the Tableau workbook. There are a few other things to note, like turning off the aggregate measures in Tableau and a few other things, and all of that is available in the Plumber Tableau documentation as well. And with that, you can use the model results just like any other measure in Tableau. Use it to color in your values, in your toolkits, and so on. So here we're seeing the predicted occupancy at various parts of the city as calculated by our model. And we can call R code from Tableau as well. When we change the arguments that's sent back to R through the API that's hosted on RStudio Connect, the API serves these requests and sends back the updated results, and those are shown in Tableau. So this is showing predictions from the model object we created in R every time we change the days in the future or the block ID. And so say that you wanted to update your model, all you have to do is change the code that you wrote in R, and the updated model will show up in Tableau. You don't need to change anything within Tableau itself unless your arguments change or something like that. Another option for using R and Shiny together is the Shiny Tableau package. While the Plumber Tableau package calls R from Tableau, the Shiny Tableau package embeds Shiny apps in Tableau. You can use special code when creating the Shiny app so that Tableau can read it. And the Shiny app can interact with the rest of your dashboard, such as pulling in data from our worksheet to populate your chart. So this lets you use ggplot2 visualizations and other types of Shiny apps within Tableau. And so the authors of Shiny Tableau have created a great walkthrough on how to set up Shiny Tableau, creating the extension, and using it within Tableau. I highly recommend checking it out. And you can deploy Shiny Tableau extensions like any other Shiny app, which allows you to use them in production. RStudio offers RStudio Connect and shinyapps.io as options for hosting your Shiny apps. So let's walk through the steps. Once Shiny Tableau is installed, the first step is editing what's called the manifest YAML file, which contains metadata for your extension. And the next step is to create the extension. So in addition to creating a Shiny app, we also need to configure the app so that it can interact with Tableau. And there are specific instructions on how to do this. This is the most technical part of the whole workflow because you are building a Shiny app. But the Shiny Tableau tutorial details how to do this very thoughtfully and with a lot of detail. So once you run the Shiny app, a dialog box will appear. We click download to download a TREX file, which is what Tableau will use to create the extension. And then we move over to Tableau. We open the workbook that we want the Shiny app to be in. So in this case, we'll use the Superstore workbook. And from here, we build the Tableau dashboard that we want with the figures we need and the data we'll be using. And when we want to embed the Shiny app, we use that TREX file that we downloaded earlier and add it as an extension in the dashboard. So now the Shiny app is in Tableau, but it doesn't know what data to use. So the next step is configuring the extension so that it works with Tableau. This is what the specific Shiny Tableau code in the Shiny app does. It makes sure that Tableau and R can talk to each other. And once we configure it, we can use our Shiny app within Tableau. One neat thing is since all of your R code is in your R environment, Tableau users won't even necessarily know they're looking at something created in R because of how the Shiny apps are embedded in the dashboard. So using the powers of R and Shiny, we can use our available tools to create dashboards that show what we need to show. And just a note, Shiny Tableau is still experimental, and we'd love your feedback on what you hope to see from the package. So we've seen a few examples of how interoperability makes our work better. But one thing that I think is particularly great is being able to work in one place. There's two ways that I want to show how we do this in R. First is being able to use specialized tools to work within an R script. And second is the language engines available within R Markdown, which lets us use other languages within the same R Markdown document. So we actually just saw this in the reticulate example, where we called a Python library in an R chunk and then also ran code within a Python chunk. But I want to show two more examples of what this looks like and demonstrate a couple more packages along the way. First, let's look at some more specialized packages. So dplyr is the backend database for dplyr. It allows you to use remote database tables as if they were in-memory data frames and automatically convert dplyr code into SQL. And R2D3 is a package that interfaces R with D3, which is a JavaScript library that creates very beautiful visualizations. And we can use all of them together in R rather than having different places for our database query, our R script, our JavaScript code, etc. So let's go into another R Markdown file, which again, you can find in the RStudio Cloud project. And as usual, we set up our libraries. So for today's walkthrough, we're going to create a database from scratch. So using the data from the R2D3 vignette. Although it's not the focus for today, use this is another amazing package that makes working in R so much easier. It also works very smoothly with GitHub. I highly recommend checking it out if you haven't in the past. And here I'm using the use GitHub function from useThis to pull the vignette files from GitHub. So first we're getting the data file from the vignette and then the JavaScript script. And so they're automatically saved within our project. And so let's read in the CSV we just saved from GitHub as D3 data. Here we create an in-memory database using R SQLite and DBI. This database has no data in it, so we copy over the D3 data using copy2. And we retrieve a table by using the table TBL function. If we run the function show query, we can see the SQL equivalent of what we just did, which was to select all from D3 data. So let's see what working with the data looks like. SQL is perhaps the most common querying language out there. The goal of dplyr is to automatically generate SQL for you so that you can continue using the dplyr syntax from the tidyverse instead. So here we use a dplyr pipe to manipulate the table just like in a regular R workflow. We filter the table so we can keep the rows where adjusted close is greater than the average adjusted close. And then we arrange by descending date. So then the dplyr function collect shows us the results printed on our screen. Then we use the dplyr show function show query to see the SQL equivalent of what we just did, which is pretty cool, right? So let's see another example. Here we're summarizing across all the numeric rows to calculate the mean of each row. Again, collect shows us the results. We see in a single row here. And then again, we can run show query to display the SQL equivalent, which is here. And to showcase the R2D3 example, we use the data and the JavaScript files we downloaded from GitHub earlier. With that, R2D3 can render the data and the JavaScript code and create a D3 visualization. So here's an example of what it would look like, a D3 visualization made with an R package. So again, using the dplyr and the R2D3 packages, we can interface SQL and D3 and use those languages within our R Markdown document or R script. That means anybody wanting to run the code that you just ran can use the same R Markdown document to download the data, do some queries, create a visualization, regardless of their language of use, and without having to switch to a JavaScript file, run things in a database management system, etc. So now let's take a look at R Markdown. You can run this function here to see the list of all the language engines available in R Markdown. It's a really impressive list, and there's more information in the R Markdown cookbook. This means that R Markdown supports all of these languages, and to use a different language engine, you change the language name in the chunk header from R to the engine name, like when we used Python in the Reticulate walkthrough earlier. So let's take a look at one more example. This is from a 2011 walkthrough called How Much R is Written in R. And to do this, we need a copy of R version 4.1.2 from the R project saved as a folder in our project. And so the author of the walkthrough looked at the source package to record the type of files in the archive, how many lines of code, and the file names, and then converted the results into a CSV. Then the author created a bar plot to answer the question of how much R is written in R. So again, the author used a shell script to look at the source package. The shell script hops across the R version source folder and records each R, C, and F file, and how many lines of code are in each one, and the name of the file. Admittedly, I do not know how to write shell scripts, so I very much appreciate the author publishing the code on their website. And additionally, I also really appreciate I didn't have to run the shell file outside of my R Markdown file because I could use the shell language engine to run it, seen here within the curly brackets. Then we run all of this code, and then we clean the CSV back in an R chunk. Again, this is all within one R Markdown document. It's pretty amazing. Anybody can open this up, run the analysis without having to go into their own terminal. So you can do this for all different versions of R to see how much R is written in R yourself if you're interested, since interoperable tools make that possible. And in terms of results, as of R 4.1.2, about 59% of the R core is written in R, and 30% of the lines are in R. So R itself is able to use other programming languages in its own creation, showing how important and powerful interoperability can be. So in addition to Reticulate, Plumber Tableau, Shiny Tableau, dbplyr, R2D3, there are tons of packages with and without hexes that interface with other tools. Just to mention a few more, RCPP interfaces with C++, TensorFlow and Keras are able to use the Reticulate package to create interfaces with the TensorFlow and Keras libraries for machine learning. Plumber, mentioned during the Plumber Tableau walkthrough, helps create APIs by decorating your R code with specific comments. The Arrow package lets you use language-independent memory for flat and hierarchical data. And the Feather format lets you work with the same data across languages without having to save and reload it. Like I mentioned, there are tons of packages I missed, so please feel free to share them in the chat and we can perhaps build a library of interoperable tools. So in conclusion, I hope this talk was a good overview of why interoperability is important and how the possibilities of using R interoperably makes it more powerful and flexible. It lets you use tools that already exist to your advantage so you can choose the right one for the job and make your data science work easier. So with that, thank you. Please stay in touch. You can find the slides and resources on GitHub. If you do end up using any of these packages, please reach out to me. I would love to hear about your experience. And again, I appreciate the opportunity to chat today, and I hope you have a great rest of your conference. Thank you.
Amazing. Thank you, Isabella. That was a lot of useful links and information. For sure, I will double check the video and watch it a couple of times. We have a minute for one question, and I think that's pretty important. You were talking about using Tableau and R and Shiny at the same time. There's a question on the chat regarding that part. So if you use Tableau in your company, do you need to have an additional server for R or for Shiny to connect, R server computations inside Tableau?
At least using these two packages, yes, that's right. For the Plumber Tableau package, for example, RStudio Connect is used to host the API. There are perhaps other ways of hosting that API, say locally, but we do not recommend that. That is not as secure as hosting it on something like RStudio Connect. For Shiny Tableau, similarly, it depends on your Shiny app being open in order to display it in the dashboard in production. And so if you were to close your Shiny app, it will no longer show up on your dashboard. So yeah, you do need a way to host your app like regularly, like, or consistently in order to use it, unless you are planning, say, to run the dashboard, run the Shiny app anytime that you intend to open up the dashboard.
Okay. Okay, thank you, Isabella. I think it's time for another talk, the keynote presentation by mine, and I'm really excited to see another talk as well. Thank you for your time again and the energy you had and clear walkthrough, and hope to see you sometime in person and hopefully next year during YR as well.
For sure.